Welcome to another episode of Grammar Cookies. This time about the optional cell. First of all, thanks to everyone who commented and provided feedback on the last video, who shared it, who liked it. All these kind of things really help me to stay motivated and do these videos for you. So big thanks for that. At the end of this episode, I'm going to say that the next one is about the bracket cell. It is not going to be the next one that is about the bracket cell. I decided to put in a video about more fundamental things in grammar cells first. If you aren't interested why, just skip ahead now to the next chapter and that's where the tutorial will start. Okay, so the reason why I'm not going to talk about the bracket cell next is that I don't think it really fits the flow of this series right now. I pre-recorded the first 4 episodes a couple of weeks back, and since then changed my plan on how to structure them. So right now I'm not going to do the next one about the bracket cell. The next one is going to be about fundamentals in grammar cells itself. It's not going to be a real tutorial. It's going to be an explanation of how things work behind the scenes, etc. Because all the editor cells I'm going to talk about next are not only cells that generate boilerplate for you as the ones that I talked about so far, but they involve some sort of parsing in the editor. And now you might have a bunch of questions because MPS is projection editor, so how does parsing and all of this fit into the game? But that's what's going to be answered in the next video in more detail. Then the video after that is going to be about the rule cells in general. And then I'm going to talk about the bracket cell that I originally planned as the next one. So make sure to subscribe to the channel if you want to get notified about these new videos as well. So let's get into the optional cell and head over to the computer.
Grammar cells optionals. Grammar cells optionals are useful when you have optional children on your concept and you would like to provide a keyword like editor for these kind of situations. So let's take a look at this toy language here. So we have a class and we would like to express that it extends another class. So what the user naturally would like to do is type extends and then the extends relationship can be expressed. So how was this implemented? First step, let's take a look at the language definition. So we have the class concept here that has 2 children. Obviously, both of them are optional. One is 0 to 1 and one is 0 to n. So we have one optional child for the extends relationship and multiple children in a list that is also optional for the implements relationship. Then let's take a look at the editor because that's where the actual implementation happens. And as you can see, to no surprise, we are using the optional cell from grammar cells. And inside such an optional cell, you always find a collection of editor cells. So here we have the collection of editor cells. For the extends, we basically define a constant extends here, and then we reference the child that we would like to use there as well, which in this case is the extends child, which is optional. And that's all we need to do. Grammar cells will actually infer from this definition that there's the extends text that the user wants to type, and then fill the extends child with a value. And the same also works for lists of children, for instance. So here for implements, we have the same thing. Static constant editor cell with the word implements, and then a reference to the implements children, which is a list from 0 to n. And it behaves the exact same way. So if we type implements, we get our child list populated and the keyword shows up. And it also works when we actually empty the list, the keyword disappears, and the same would also apply for the extends relationship. So for this, you don't need to do anything. Everything you saw so far is generated for you. And it also works with string properties, which can be quite handy in some occasions. So if you have a string property, and you want to have an optional value for it. In this case, I have this alternate name thing here. It also works. So if I go here and type with alternate name, then I can fill that string property with a value. And when I remove the property value, the text also disappears. So it does not only work for children, it also works for properties, but in this case, string properties. For Booleans, of course, it wouldn't make much sense. Okay, so but what if you want to customize the text that shows up and that the user should type? That's also possible. You go in your editor definition and you take a look at the inspector of such an optional cell. So what we have here is we have this transformation text. I can show you how it looks like when it's not there. It looks like this. And if you create one, you have a function. You can write code basically where you get access to the node, where you can then return either a string or a sequence of strings. Now you might ask, why should I return a sequence of strings? Because as you've seen before, it doesn't show up in the editor right away. So if I go here, I only see the three options, right? Extends, implements, and with alternate name. That's the things we would expect. And that's also the first one here from the list. But what does grammar cells do with the other ones? The other ones are useful for cases where the user directly types the text. So if I type alternate, while it wouldn't match any text in the code completion menu, right? Because it's not there. Yeah, if we go here, there's none. But since we returned that text as well, grammar cells will match against that text. That can be useful, for instance, for correcting typos, or for having alternate names for the same thing. Sometimes when you do language migrations, this can be handy. So don't wonder if it doesn't show up in the editor. Only the first one shows up in the code completion menu right away. Of course, you can also just return one string here in this case if you just want to change the name to something different than what the user sees. Might be a little bit confusing, but there might be reasons why you want to do this. Okay, I hope you like this. You can find the source code in the usual place. Take a look in the video description. It's linked there. And then next week, we are going to take a look at splittables. Splittables are a nice way to implement something like string literals and getting some benefits on top of that. And yeah, get subscribed if you haven't to don't miss the next episodes, and then talk to you next week. Bye.